welcome to this presentation about the... Oh, sorry, can you show the slides, please? Thanks. So this presentation is about the exploitation of XSS vulnerabilities in webmails. In the past years, numerous vulnerabilities have been found in desktop mail applications such as Microsoft Exchange, Microsoft Outlook. But during this research, we realized that many webmail software, including the most important open source ones, are particularly vulnerable to XSS attacks, which can be triggered remotely. So I'm Matthieu, senior malware researcher at security company ESET, and I actually work from our research office here in Montreal, where dozens of researchers specialize in tracking cyberespionage groups. So most of you here are probably familiar with the concept of XSS, especially if you have participated to a CTF before. But I would like to take a few minutes to clarify what is the XSS in order to enable everybody to fully understand the presentation. So XSS attacks, it's like cross-site scripting attacks, are a type of injection in which malicious scripts are injected into otherwise benign, untrusted websites. So basically, it happens when a web application uses input from a user within the output it generates without validating or encoding this data. And the input can be used as output for the same user or for a different user, which is slightly worse. And if you carefully read the conference agenda, you might have noticed that one of the presenters actually tried to add an XSS in his biography, but it was sanitized by NorthSec website. So in this case, the input is a biography entered by the presenter, and it is displayed to all visitors or NorthSec websites. And there are several types of... Yes. Nice. So there are several types of XSS, including reflected, stored, and blind. And I have here a very small example of a reflected XSS in JavaScript, but XSS vulnerabilities can happen in any language used to generate web page, like Python, PHP, etc. So this is really small scripts that add what is passed via the URL parameter MSG to the web page using the document.write function. So, for example, if we add in the parameter NorthSec is the best conference, you can see that it's directly added to the web page. There is no problem, it's just text. But what if we add JavaScript code instead of text? So actually, if we add an alert between two script tags, then we can successfully execute like JavaScript code in the web browser. However, this XSS is not persistent. An attacker will have to entice the victim to open an URL in which the malicious script is already present. Then there are store XSS. It's like the second type. The injected code is already present in the web page and is visible to all visitors. So remember the biography in the NorthSec website. It would have been a stored XSS. And another example could be like a user posting a message on a forum. So if they had some JavaScript code in the forum message, then all visitors who are going to read this message will execute the JavaScript code in their own browser. And finally, blind XSS, it's almost the same as stored XSS. The difference is that the attacker cannot see like the page or application where the code is executed. For example, it could be like an admin panel where you can see external messages. And yeah, regarding the impact, so first, those XSS, they allow to execute JavaScript code in the context of the browser, of the context of the web page, but of course it doesn't allow to like escape the browser or execute code directly on the machine. It's really in the context of the website. So what you could do is, for example, redirect a user from a trusted website to a malicious one. You could also inject an exploit in a trusted website to do a watering hole and try to compromise the physical computer. You can also perform actions on the website instead of the user. So if the website has an authenticated API, for example, since the code is running in the context of the web page, he has all the rights the logged in user has. So for example, you can read data and exfiltrate it. And you can also steal cookies that are tied to specific domain, like to the specific website, because once again, you're running as any script in this website. So now that everyone knows what is a XSS, let's see why it is a common vulnerability in webmail portals. So actually, we can describe a webmail as a web interface that displays untrusted HTML content, the content being emails. And during this research, we found 4 different webmail applications that were targeted. So Zimbra, RuneCube, Ord, and MDMon. And yeah, those applications, they are running on the org premises. It's not like a cloud service like Gmail. It's some applications that you install on your own mail server. All those software, they implement some XSS preventions. For example, it's impossible to just add an alert in between 2 script tags, but often those sanitizers, they are based on regexes or hard-coded deny lists. So attackers, they can either find a way to trick the HTML parser or to bypass the filter. For example, the RuneCube sanitizer, it's what they call the washer, and it's nice with RuneCube because it's open source software. All the code is on GitHub, it's in PHP, so it's quite easy to read. And there is this rcube washhtml.php script, which is responsible for sanitizing emails that contain HTML to forbid the execution of JavaScript code. So this script includes a list of allowed and forbidden HTML elements, and you can see that only 4 elements are completely forbidden: script, applet, embed, and style. And I won't show it here, but even for allowed element, there is a list of allowed and forbidden attributes, because often only specific attributes of specific HTML element are potentially harmful and could allow to execute JavaScript code. So I have selected 4 vulnerabilities in webmails that were exploited in the wild. There are many more, but I believe they're quite representative of typical flaws you can find in those sanitizers. So the first example is a vulnerability in RuneCube, which is tracked as CV 2023-5631, and it's a 0-day that was used by a threat actor known as Winterviven in 2023. I will provide more information about the threat actors in the last part of the presentation. And we reported it to the vendor, and it was patched in just 2 days. So they were quite efficient in patching the security flow. So you can see the email on the right. It's contains HTML, and it impersonates Microsoft, I believe. And at the end, you can see there is some SVG element, and inside the SVG element, they try to add another SVG element, which is like the base 64 encoded parts. And you can also see that there is an extra white space between the S and the VG. And theoretically, RuneCube want to prevent adding a SVG inside an SVG because the base 64 part is not sanitized, and actually you can add a lot of other HTML elements inside an SVG element, and you can actually execute JavaScript code. But here the problem is that there is a white space between the S and the VG, so it's not correctly detected as being an SVG picture. And if we decode the base 64 payload that was in the use tag, you can see it's another SVG with an image and some JavaScript code in the on-error attributes. And what was the fix? Actually quite simple. They just add a call to the trim function, which remove all white space. So now the S tab VG will be converted to SVG and will be correctly detected by the washer. So it's very simple trick, but it shows that those sanitizers are really not robust. Second example in MDMon, it's CV 2024-11182, and it's a 0-day used by another APT we call SendNet, and it was used in late 2024. Once again, we reported to the vendor, and it took a bit more time to patch it. So they did some beta version in 30 days, and then almost a month to get like the final, like the real release with the patch. It's once again HTML email, and it's at the top that the XSS payload is. So if we zoom a little bit, we can see that they first open a no-embed tag, then a p tag, and then in the title attribute, they actually close the no-embed tag and open an image tag. So this should have been part of the title and considered as text, but there was some, I guess there was some confusion in the HTML parser used by MDMon. Unfortunately, like their parser is developed in C, and it was a bit of pain to reverse it, so I didn't really find what was the exact problem. But there is a confusion between the parser used like for the sanitizer and the parsers used in web browser. So there is a difference which makes that like the HTML tree that is generated is different for both. And actually, if we test in some test environment and install MDMon and created like some email with the payload, and we can actually execute JavaScript code in the browser. You can also see here that I didn't use the exact same tags, so I use a div and a style attribute, so it shows that the confusion in their HTML parser is not related to only one HTML element, but there is a bigger problem in how they parse HTML. The third example, it's in Zimbra. It's a CV 2024-27443, and this time it's an end day, so it was already patched when the threat actor started to use it, and it was also used by SendNet in 2024. And yeah, we are not the original finder. We did not disclose the vulnerability to the vendor. And in this case, the vulnerability lies in a email header, specifically the X-Zimbra calendar intended for. And actually, if we check Zimbra code, we realize that the content of this header is directly added into the web page without any sanitization. So if you put JavaScript in the header, then when the person will open the email, the JavaScript code will execute. So what they did is to add some sanitization to the msg.cif, which contains the value of the header. So this time, the payload was not directly in the body of the email, but in a header sent by the mail server. And the fourth example, which is also in RuneCube, again, end day vulnerability used by SendNet in 2024. And this one is quite interesting because the vulnerability is not directly in the washer, but in the hyperlink functionality. So in RuneCube, you can create hyperlink, and you can like provide a display text to display inside of the URL. Unfortunately, it seems that we can add JavaScript between the brackets instead of just raw text. And the problem was in some regex that they were using to find this replacement text. And actually now they just forbid the less than and greater than characters. So simple fix, but yeah. Once again, it shows that all those sanitizers are made with hard-coded list regexes, and it's not that hard to bypass. I have two more examples, but they are quite fresh, so I decided not to show how to exploit those vulnerabilities. The first one is another XSS in MDMon exploiting another flow in the HTML parser. It was actually used as a 0-day by SendNet a few weeks after their first vulnerability was patched. So this is a bit the story of our research. And the second one was recently used by Winter Wyvern in the wild, and it's quite similar to the Zimbra vulnerability in the calendar intended for header, but this time it was in a field of calendar invite, so the .ics attachments. And actually, in one of the fields, you could add JavaScript code, and it's not properly sanitized and displayed to the final So in this third part of the presentation, I'd like to showcase what threat actors are doing with those vulnerabilities. So it should help not only defenders, but also, for example, red teamers to give them ideas what you can do when you have XSS. And so the first example, so I will go by group. So the first group is SedNet, which I mentioned in the previous section. And SedNet is also known as APT28, Fonsiber, Forest Blizzard, or Sofacy, and many other names. They are responsible for high-profile incidents. For example, the attack against the Democratic National Committee in the run-up for the 2016 elections in the US. They also attack TV5 Man, the World Anti-Doping Agency, etc. They are publicly attributed to the Russian GRU, which is the main intelligence agency of the Russian military. And it's a big group. They do a lot of operations. So they do spear phishing, but also exploitation of vulnerability. They use implants, sometimes complex, sometimes very basic. And right now, most of their operations are very focused on Ukraine. During our research, we found that they were targeting those 4 different applications: Zimbra, Ode, MDemon, and RuneCube. As I mentioned earlier, so those applications need to be installed on-premise on the mail server of the organization. So they are not targeting like those companies, but organizations that are running those products. So we call this Operation RunPress, so the specific operation by SedNet against webmail application. There was targets in Ecuador, Bulgaria, Serbia, Romania, Ukraine, Greece, Cyprus, and Cameroon. Most of them being in the field of defense, national government, also aerospace companies. And most of the targets were in Ukraine, so there are different countries, but let's say that 80% of the targets were in Ukraine. This is a typical chain, so not only for SedNet, but in general, when an attacker uses XSS vulnerability in a webmail application. So an attacker will send a malicious email with a specially crafted either body or email header, etc., to exploit a vulnerability. Then the victim needs to read the email inside the vulnerable webmail. If it works, the XSS exploit is triggered, and it will load in-memory arbitrary JavaScript code. So generally a stealer that can steal a lot of information, like sometimes credentials, but also like contacts, emails, 2FA tokens, login history. And what is like one of the problems for attackers is that there is no persistence. So as soon as the web page is closed, then the script stops running. And if they want to get like fresh messages, they will have to convince the target to reopen the malicious email again. So what they can do instead is to create a redirection rule, so generally a sieve rule that will send a copy of every email from the inbox to an attacker control email address. The victim should open the email to trigger the XSS, so the title and content should be attractive enough. In the case of Operation RunPress, they generally copy-paste articles from legitimate news websites. Now I will show a few of their stealers. So the first stealer they have is a credential stealer for MDemon. And what they do is that they simply create a hidden form for the username and password, and the goal is to trick password managers to actually fill the saved credentials there, and if it works, then the credentials are exfiltrated, and it's not like visible to the victim. They also have an email stealer. They will actually list emails from specific folders and then exfiltrate each email to the CNC server with HTTP post request, because like it's a the JavaScript code can just create a HTTP request to a CNC server and exfiltrate this data. More interesting is this 2FA stealer for MDemon, because actually the script is like an authenticated user, and it can access like the QR code containing the token you use to enroll your account in your 2FA application. So they can just steal this QR code or code and use it to generate 2FA codes online. So if they steal credentials and they're able to generate 2FA codes, then they can log in whenever they want to the victim's account. And another option to bypass 2FA is to create application passwords, because once again, they can control like the mdaemon API. So they will. So an application password, generally you use that if, for example, let's say you use Thunderbird to access to your emails, but Thunderbird is not necessarily aware of 2FA. Like you type a password, but you cannot necessarily type a 2FA code all the time. So to bypass that, sorry, you can create a specific password for an application. And if you enter this password, no 2FA code will be required. And what is even more dangerous is like if you change your main password or even activate 2FA, if this application password still works, attackers can still access your mailbox. And finally, I talk a bit about sieve rules at the beginning. So this is how it looks like, the payload that creates a sieve rules. So it does a HTTP post request to the RuneCube API and add a rule that will send a copy of every email received in the inbox to this attacker control address, so the skiff.com email address. Yeah, so this is the only payload that has a kind of persistence because the sieve rule, they're actually running inside the mail server. So even if the person is not logging in their session, those sieve rules are directly executed by the mail server. The second example is a group we call Winter Wyvern. It's a Belarus-aligned APT group. They're closely related to another APT we name Mustache Bouncer. We have published a blog post about them. And Mustache Bouncers, they are quite interesting because they are doing adversary-in-the-middle attacks to compromise foreign diplomats in Belarus, and they were operating only inside the country. On the contrary, Winter Wyvern is a bit less sophisticated. Their focus is more on initial access, but they do target foreign entities, so not only targets inside Belarus. So they mainly target Zimbra and RuneCube, so no Horde or not mdaemon. And for the victimology, we have found victims in France, Poland, Ukraine, Georgia, Pakistan, and Uzbekistan, mainly think tanks, national governments, and also military entities. So here is a credential stealer for RuneCube. So it's a script I found on GitHub, and it was probably uploaded by the victim. As you can see, the victim is the MOD of Georgia, like the country of Georgia. And the strategy of Winter Wyvern is to steal credentials. The strategy of Winter Wyvern to steal credentials is very different from the one of Sednet. They are not going to create a hidden form. What they do is they first log out the victim for the session, and the script interacts directly with the API, so the victim is not redirected to the main login page. And the script is also aware of CSRF tokens because it's running inside like the website session, so it can of course get new CSRF tokens all the time, so it's not protection against those kind of attacks. After logging out the victim, then the script will show a new signing form, and the script controls the submission of this form. The credentials are not directly sent to the RuneCube server. And finally, the script tries to authenticate to the legitimate webmail server using the provided credentials. If it's successful, those credentials are then exfiltrated to a CNC server. So overall, it's quite transparent for the victim. All the time they were on the official domain of their organization, and it would be not so surprising to be logged out from time to time and having to log in again. And yeah, once they have provided their credentials, they are really logged into the real webmail. So the last group that we have seen exploiting vulnerabilities in webmails, we call them GreenCube. They're also known as UNC 3707, and it's a Russia-aligned APT groups. This group is way more basic. They mostly do spear phishing, like creating fake logging portals for like cloud mail services, or also like institution portal, and they also exploit XSS in webmails. Actually, only in one webmail in RuneCube. As for the victimology, we found victims in Greece, Serbia, Poland, and Ukraine, mostly in the sectors of defense, transportation, justice, and national government. So this is an example of their email. As for SendNet, they are copy-pasting a news article. This one is about elections in Serbia in 2022, if I remember correctly. And they're exploiting a vulnerability in RootCube. In this case, like the screenshot, I display like the email in Outlook. So that's why we can see like the big base64 and the exploit. But if you see it in a vulnerable RuneCube instance, it will like execute the code instead. And it's vulnerability I didn't talk about before, but it's very similar to the one from 2023 with the hyperlink functionality. So it's once again some kind of problem in the creation of hyperlinks. And also what is funny with GreenCube is that the payload is fully hard-coded in the email. For example, for other groups, generally they use a second stage downloader that will get the final payload from the CNC server, so they can easily update this payload or deliver multiple payloads one after the other. But GreenCube is the one, for example, to first steal credentials and then steal emails. They will send two different emails, and the victim will have to open like those two malicious emails one after the other. They have a safe payload, which is quite similar to the one from SendNet, so it will redirect all emails sent to the inbox to an attacker-controlled email address. And they have a credential stealer payload. It's also hidden form. And when we tested last year, this technique will trick like default password managers of Firefox and Chrome, but it was not working in Safari. I'm not sure for other password managers like 1Password, LastPass, etc. But probably the behavior is different from one password manager to another. But it works in some cases. And they also have an email stealer payload to steal all emails from the inbox and exfiltrate them by doing HTTP requests to the CNC server. Now let's quickly talk about prevention. Unfortunately, there is not much to say. The main thing is for webmail admins to keep like webmail instances updated, because I mentioned 2 0 days, but actually even SendNet, they use those 2 0 days against like 3 organizations, but all the other phishing campaigns they did was with known vulnerabilities that had been patched for months. And for users, the problem is that even like no script will not block the script, because if you allow list the webmail domain, like to use the full functionality of your webmail, then as the script is running inside this website, it will be allowed to run. So as a conclusion, a lot of software are affected, including the most popular webmail, Zimbra, Horde, RuneCube, and MDMon. And XSS vulnerabilities enable to execute arbitrary JavaScript code in the context of the browser. And it can be triggered remotely by just sending a specially crafted email. It enables to steal whatever is accessible to the webmail user, including emails, contacts, 2FA tokens, and it can also be used to trick the user into providing their credentials. And finally, in this research, we found that this modus operandi is mainly used by Russian and Belarusian cyberespionage groups. So if you want to get all details, we have 2 blog posts, one a bit older about Winter Viven, and a second one about SendNet that we have just released today. So you have the links, and QR codes are also pointing to those blog posts. Thank you for your attention.